Good evening, everyone. Am I audible? Okay, great. How are you all? Yeah, I'm good. Thank you so much for asking. Okay. I can see that people are still joining the class. Let's wait couple of minutes and then we'll begin the session. Yeah, I'm doing good. Thank you so much for asking. No, if you missed previous classes, then it's not going to affect the today's topic that we will learn. Today we are going to learn a very totally new topic, okay? So it won't affect that. Okay, so I guess everybody is here, and without any further delay, let's start the class. So before I begin, let me confirm one more time. Is the screen visible to you all? Okay, thank you. Okay, so in our previous class, what was the topic that we studied in our previous class? We talked about the ER model, right? Yes. And then we, after that, in ER model, we understood what is entity, attributes, then relationship, okay, and then the types of relationship between the tables, okay. So let we understood the concept of entity relationship, okay. What is ER model? So if you are asked, like if you are asked how to draw any kind of ER model, then how are you going to do that? Because of course later on, if you will be creating the tables or anything, if you're working with the tables, okay, so maybe there's a scenario that before actually implementing the table, you need to design it, like you need to create the model of the table that you are going to create, right? So for example, you want to create a table, or like you want to create a ER model of a student database or a school database, okay. Then how can we do that? So first of all, you need to identify the attributes that you need, okay. Like for example, if I would visit any school and I'll have a conversation with the principal or any management over that school or university, okay, then first of all I'll generate the list, right? Like what do you want me to include? Like if you want me to create your database, then what are the things that are required? Yes or not? I'm going to ask, like, then maybe he would say that there are bunch of students. I want to keep the record of the students. There are bunch of staffs. There are bunch of teachers. Okay. So when such tables are created, then they are created in such a way that they have relationship with each other. And why they are going to have a relationship with each other? We have already studied this, right? Because in a single organization, if any one of record is stored in a single table, for example, I have a table of a student, okay, then in student table I'll have the record of the student only. If I have course table, then in course table I'm going to have the information of the courses only, right? But of course, the student, for example, here student ABC, named ABC, has taken a course XYZ, then they are connected with each other. The student table is connected with the course table. Yes or not? So we need to identify the relationship. We need to create the relationship in that way. We need to create tables, implement tables in that way. So in order, before implementing the table, what do we need? We need to create an ER model. Okay, what do we need? We need to create an ER model so that we would have a blueprint of the things that we are going to create or we are going to implement. Okay, it's not only about implementing. Maybe if you want to work on the table, then from the ER model you would get the concept what kind of values are stored or what kind of attributes or data are stored in that table. Okay, so for that I'll give you one example. So if I want to create a student database management system, okay, like school database management system, then how can I draw an ER model for that? So for that, I need to identify the things or the tables that I need. Okay. Like if I am asked to create, we are creating an ER model. Okay. Create an ER model. Then how would I do? So first of all, I would identify, maybe I would need student table, right? Then I would need some course table, lecturer or the teachers. Okay. And then after that, I will have some subjects or anything. So if student is student entity or not, student is going to be entity, right? Then this student would be my entity. And this entity is going to have some kind of attributes. Yes, so attributes are something that the management will tell us itself. Like I need a table where I need to have the student's ID, roll number. These are the information that I need. So while creating an ER model right now, we can take a guess. So what are the attributes the student can have? Obviously, the main thing is that the ID, and ID would be my primary key, roll number or whatever. Okay, so that would be the thing over here. Maybe here the student is going to have a age, okay, and this age can be a derived attribute from date of birth. Then it The student is going to have name. This name can be divided into a middle name, and then first name, then last name. Yes, then student is going to have address. Okay, and this address can also further be divided into like street number. Yes, then this can be divided into city and all, right? Then in the same way, student can have hobby. So hobby can be multiple. So you can have like this, okay? And gender or date of birth. So basically, this is the idea that what are the attributes a student gonna have, right? That the idea the student gonna have. Now, in the same way, if I have a course table over here, okay, if I have a course table, then course is an entity, and in the same way, course is also going to have course ID. That would be my primary key, right? So I'll underline it like this. In the same way, there would be like course name, course duration. Yes, there can be other entities also. Now we need to show the relation between these two entities. So if student is my entity and student is a table and course is my also table, okay, how can I have a relationship between this? Either I can take the student ID, this foreign key, and place it over here, right? And make it as a foreign key. Or what can I do? Here I can have course ID. That if this is the primary key, course ID is the primary key of course table, then I can create link between these two table. How? By making a foreign key. Yes or not? And many students are going to take many courses. Is that relationship or not? It's not like one student will take only one course, okay? But there might be a chance that many students might take a single course, okay? Uh, my voice is clear. I'm getting some responses that the voice is not clear. My voice is clear, right? Yeah, so there's one person who's saying the voice is not clear. Maybe it's the internet issue on your side, okay? Because I'm getting it's very clear. Okay, thank you. So here what we will do, we'll show the relationship people. So from here I'll bring this, and a student will take a course, right? Student takes course, and many students can take many courses, okay? Or many students can, it's not like many students can have one course. Let's take in that way. So this is many to one relationship, okay? Many students can take a single course. Now, in the same way, if there is students, then we are going to have some teachers, right? I will have an entity that is teachers. Yes or not? In the same way, this teachers is going to have teacher ID. This could be my primary key. Then teacher's name, addresses, okay? Everything, others entity, you can decide yourself. So there is going to be a relationship between the student and teacher, okay? There is going to be a relationship between the student and teacher. Student, teacher is going to teach the student, right? Teacher teaches student. So relationship could be something like teacher teaches students. Okay, so what is the relationship going to be over here? Like one teacher can teach many students. Yes or not? One teacher can teach many students. So the relationship between this is going to be one to many over here. Okay. Like one teacher can teach many students. Now, in the same way, teachers are also going to take the course. Like, for example, if I have multiple course, yes, like I have BTech, BBA, BCA, different type of courses are over there. Yes or not? Then it's not, some teachers are going to be in particular faculty, some teachers are going to be in particular faculty. So teachers are also going to take the courses. right? Take the courses as in not teaching the courses, but it would be decided that a particular teacher is for a particular course. Okay. So that means here teacher will do what? Teacher is going to, teacher takes the course. Okay. And here what is going to be like many teachers can go to many courses. It's not like for a particular course I can have a one teacher. Like many teacher can teaches many courses. Okay, it's not like only one person knows one subject or anything. Then there can be different thing. And now we can have a subjects also. Like in one course we can have multiple subjects, right? In one course we can have multiple subjects. So here if this is going to be connected, it will have course id, like this teacher and this course is connected. Okay, then this is going to have, here we will have a course id as well, and this here which teacher is teaching which student, for that I will have this id also in order to create a relation. Okay, this is my foreign key, this is my foreign key over here. In the same way subject, so name of the subject would be over there, right? Then after that subject id would be over there, that would be my primary key, right? Now in a single course there are going to be multiple what? Students will take the course only. Are student and subject going to be connected with each other? Do you think the student table and subjects would be connected? Because once if student chooses one course, for example student chose the btech course, then whatever the subject is in btech, that student have to take, like it is would be decided by the course itself. If I am a student and I took btech, okay, then what I will do is that I will have a relationship between the course and subject table. The course has many subjects. I mean, one course has many subjects. btech course has many subjects, right? So if I am a student, I take a course btech. So if I choose this course, automatically I'm going to get the subjects. Are you guys getting the point? So if I am a student and I get a BTech, okay, then for each semester, I would know myself that what are the subjects that would be assigned to me. Okay, so you don't need to have the direct relationship between the student and subject. Student and subjects are indirectly related by this course table. Okay, don't need to access. We can manage the course students by the course table itself. But so here one course is going to have many subjects, and here we need to create a relation between course and subject. So what can I do here? I can have a foreign key, that is course ID. So this is basically what the overview of ER model is. Okay, what we do, we decide entities, then we give attributes to it. Okay, and then after that there would be multiple table in an organization, and we decide the relationship. And when there is a link between two tables, like this student and teacher is going to have link, how can we create link? We will create link on the basis of the primary key and foreign key. Are you guys able to understand this? And if you are getting the question, how would we access the data from two different tables? So later on, we will learn a topic that is called joins. Okay. And in this topic, I will teach you how can we extract the data from the multiple tables also. Yeah, it's like creating a flowchart and algorithm. Like as I told you before, writing the programming, we draw flowchart and algorithm in the same way. Before implementing the database or the table, we draw this ER model. Many to one. To draw this, you are going to use the SQL language. We have already, do you guys remember in first class, I show you how to create table, how to create database and all by using the SQL language. So basically we learned there a basic table, right? How can we create tables and all. So when we will be making a complicated tables, like more than one tables for an organization, and we need to create relationships and all, then in that case we draw this ER model. Okay, and how do we implement the table? By using the SQL language itself. There it's not necessary to have the student Because let me tell you why student and subjects is not supposed to be connected. Because for example, I'm the student, okay? I took a course and the course is BTech. BTech has the ID 101. Okay. That 101 is also stored over here, that is course ID. Right? 101 is in this over here. So this course, the subject, for example, here are 5 different subjects. So the information of 5 different subjects are in this table. So if I can access the course from student, if I will just access the BTech, then I can directly know which subjects are stored in it. So there, I don't need a direct relation between student and subject. I can find out what subjects I am reading by accessing the course table itself. Okay. Now, in this way, I would like you people, not now, of course, after the class, when the class is over, you can try to create an ER model of library management system. Okay. And now I can give you some idea, like what would you need for this. If you are going to create an ER model for library management system, then what are the entities you can require? There you would need book. Book, it would be an entity. Okay, maybe author, right? Their author can be the entity. Then after that, you can have the member who is right now, who have the membership of the library. You can have that entity. You can have the librarian as the entity. Yes, you have the genre of the books, like what kind of the genre of the books is. These are the entities that you can have. In these entities, you can decide the attributes itself. Okay. Now, how are you going to decide the relationship? Like, for example, a member borrows the book, right? Like, for example, here, member BORROWS borrows book. Okay. Author writes book. Yes or not? Library issues the member, or then after that, library issues book also. Yes or not? Then book would be connected to the genre. Okay. Book would be connected to the genre. So, in this way, try this, try to implement it on your side. Okay, if you have any confusion, then I can help you with that also. And if you want to have any other ER model, like a person is asking me, can we make a cricket ER model? Then yes. If you want to try any other thing other than this library management system, okay, then you can go ahead with that also. And then you can, like, if you want to create an ER model of an organization where there is, like, yes, ER employees, departments, okay, then you can do that yourself. This is genre, author, book, member, and librarian. Okay, so just try it yourself. Is it cool? No, there isn't any. We don't, just like algorithm and flowchart. Okay, we can draw. This is the, like, drawing the, it's like designing the structure or the blueprint of the database. So we don't need any software for to create an ER model. You can either draw it on pen and paper. We can also draw it on the words itself. Okay. So now we are, let's start a new topic. Okay, this is a very important topic. Whatever the topic that I'm teaching is important, but here this is one of the very important concept of database management system, that is normalization. Okay, so first of all, we need to understand what is normalization. It's a very important concept of database management system, as I told you. Normalization is, we don't draw model using SQL. You create table using SQL. Before creating the table, that is the design that you can make on a paper or like draw over the board or anything. Okay. So here, I'll be taking your questions after this topic. Okay. So let me explain this topic first. So it's a technique to, it's a technique to remove or reduce the redundancy from a table. Redundancy means duplicacy from the table. Okay. It's a what? Technique. Normalization is a technique to remove or reduce redundancy from the table. Okay, and this redundancy means duplicacy. Okay, so you might be thinking that we can easily remove the duplicacy by using the primary key, because primary key would never allow you to insert the duplicated data, right? And you can uniquely identify a any record. So let's us understand how, what kind of duplicacy this normalization helps us to remove or reduce from our table. Okay, many times what happen is that in a table we have duplicacy or redundancy of the data, and to remove that redundancy or duplicacy, there is a method which is called normalization. Okay, if we cannot remove it fully, then what is our other option? The other option is that we can actually reduce it, right? So in order to understand it, let me quickly draw a table over here. Okay, like give me 2 minutes only. Yeah, asset property is already covered in previous. So basically we have two types of duplicacy. Okay, like if this is my table, for example, here I have SID, S name, and age. Okay, the ID is like 1, 2, 3. I have your Ram, Sham, and again there is Ram. Okay, age is like 20, 25, and again here is 20. So this is my primary key. Okay, it's my primary key. Here you can see that I have some duplicated values in S name and age. Okay, this RAM and this RAM is same, and this age and this age is exactly same. But these two are not the same person. And how can I say that these two are not the same person? Because there is always a chance two people can have same name, two people can have same surname, two people can have same age, same date of birth, same addresses and everything. Okay, but inside the database, how do we differentiate between them? Because their ID is different. Okay, one of them I have the ID 1 and one of them had the ID 3. So I know that from this, these two people are not same, they are different. And what is helping me to solve this duplicacy? This primary key constraint is helping me for that, yes or not? That I have this primary key constraint that is helping me in order to identify that this is not the case. Like these datas are unique. I have a uniquely identifying key over here. Okay, so we have basically two types of duplicacy. One is row label and another is column label. Okay, so here that I'm talking about, this is the example of label. Okay, you can see that we have taken here student ID, student name, and student age. I have put some values that is 1, 2. For example, if I make it 1 right now, okay, it's not 3 anymore, it's 1. Then this, now the first row and third row is exactly same. Yes, the row is same, right? 1 RAM 20, 1 and RAM and 20. So this first row and this third row are exactly duplicated. Previously, when the value was 3, then it was not a duplicacy, yes or not? When it was 3, then it was not a duplicate. Right now, consider that this is not a primary key. Okay. Right now, consider that this is not a primary key. We don't have any primary key over here. And then I have 1 RAM 20, and third row also I have 1 RAM 20. Okay. So right now, if you see this first row and third row is exactly same data. Okay, so when there are duplicated datas, okay, when there are duplicated datas on the row label, then we call it as a row label duplicacy. Okay, we call it row label duplicacy. And how can I remove this? I can, if I will make, instead of making this normal column, if I will make it my primary key, then it will not allow this duplicacy over here, and I can simply remove this duplicacy and I can have a ID that is 3. So here what is happened, row level duplicacy has removed. Okay, this is what the row level duplicacy, the concept of row level duplicacy is. And if you are asked how can we remove the row level duplicacy, then the answer is simply by using the constraint that is primary key. Okay, now if I talk about the column level duplicacy, okay, so here if I have a table, other rows cannot be same. How other rows can be same? Because primary key will never, if you will try to insert your 3 again, whatever the value is in s name or age, if you will try to insert it again, then you will get an error. Primary key will not allow you to insert the same ID again in that column. Okay, so other rows cannot be same if you use primary key in the table. That's not gonna happen. Okay, so for example, now if I have the student ID over here, okay, then here is my student name. Yeah, the classes are daily. Then if I have your course ID, okay, so I'll write your CID, and here I have course name. Then maybe there is faculty. Okay, so faculty ID I have over here. Then I have faculty name. Let me draw one more table, one more column. And this is maybe salary of the faculty or the employee or the teachers. Okay, you can take it as the teachers also, like teacher's ID and teacher's name. Okay, so this is the table over here. And now I will let me show you how could we have a column level duplicacy. Okay, so here 1 2 3 4, here if I have Ram, here is Ravi. Okay, then here maybe I have Rekha and Rani. Okay, then this is C1, C2, C3, C4. Maybe I have course like DBMS. Okay, then I have Java. Here is Python. Then again here is DBMS. Then teacher's ID, so maybe T1, T2, T3, and T4. Okay, the teacher is John, Bob, Anna. Let me repeat this thing over here. Okay, maybe this is DBMS. Here is John, and here is John again. Okay, maybe all of their salary is something like this. 30. Okay, so this is the table over here. Now let's us understand here in this table my, okay, I have student ID, student name, course ID, course name, then teacher's ID, teacher name, and the salary. Okay, and row label is the very easy one. As I told you, row label you can remove it very easily by doing what? By applying the constant, that is primary key. We need to, the important part is the column label duplicacy. Okay, and that is the tough part over here. In this column label duplicacy, let's start with this. Okay, here I have some value in all of the columns. Now basically, if you will look at it carefully, okay, two rows are exactly same over here. Let me make the two rows exactly same. That is, if this is also T1, okay, then this row over here, from here to here, okay, and from here to here, are these two rows exactly same? Okay, here this two rows only. Okay, I'm not talking about the whole. Here it should be C1, then it would be exactly same. Okay, so this is also C1. Then now is the exactly same. Okay, okay, now if it's C1, then DBMS, then T1 over here, and then John, okay, and then 30,000. Now it's exactly same. Okay, why? Because we already removed the row level duplicacy over here. Okay, how do we do? I told you that set the primary key, make this, it's T1. Okay, it is T1 and it is also T1. So it's same. I'm not talking about the last right now. John has that ID that is T1, so it should be T1. Okay, okay. So let's let me talk about this first. Okay, so here basically we have this three columns exactly same now, but let me talk. We have the two columns same. Okay, but here you can see that this is my primary key. So of course, in this column, I'm not going to have any repeated value, right? I told you that set the primary key, make the student ID as a primary key. So there are not two rows that can be like, there are not two whole rows that can be exactly same. There isn't. Okay, there won't be. If I will make this, like here is Ram, okay, if I'll make this name Ram as well. So even though this thing is whole same, like RAM, C1, DBMS, T1, zone 30,000 and all, but we know that this RAM and this RAM is different because of the student ID. Okay. But can the column be the same? If you'll see like here, if you'll see in the column of course ID, okay, course ID, course name, then teacher's ID, teacher's name, and salary. Okay, you need to see the third and fourth row. If you ignore this these two columns, okay, and if you will look this part of the tables only, then I have one, two, and this three. Okay, these three rows are exactly same. Okay, although I have mentioned only for values over here, but people, okay, your three values are exactly same. Okay, and when we create the database, in the database what will have right now, I have how much value over here? Only four values. I have only four records, right? So it is not making that much of a difference. But imagine in database that we can have more than thousands or in lakhs of data, right? We can have thousands or in lakhs of data, so we can have the rows. So if you see that there is a repetition of the same row again and again, of course and the student ID is primary key, and it is helping me to identify the different student. The student ID is helping me to identify the different student. The student ID is not helping me to identify the scores, because DBMS scores 1, DBMS scores 1. Okay, DBMS scores 1 ID. Teacher is the John, and that this John also T1, John also T1, and John also T1. Okay, this CID and TID does not have primary key. This is a single table right now. Okay, this whole is a single table, and in this single table I have only one primary key, that is this one. Okay, so don't you think that if I will have 1 lakhs of data, okay, 1 lakhs of data in table, and the table if look exactly like this, imagine in your head that the table look exactly like this, okay, and we have 1 lakhs of data, then student ID is helping me to identify the student name uniquely. Okay, but there's a repetition in the course ID and teacher ID, teacher name. Maybe John is teaching any other DVMS to any other student. Maybe there is a student name 5, okay, ID 5. Her name is now maybe Sanvi or something. Okay, she has also taken the DBMS course. So what would be the record for her? It would be C1, then DBMS, and then teacher is same T1, and John, and the salary is going to be 30,000. Now you can see that now same value has been again repeated. So this is going to take up so much space. Yes or not? If same value will repeat again and again, then it is going, if I have 1 lakhs or 10 lakhs of data, then my same value, okay, same information is going to take so much of space. Okay, so the problem here is that, okay, what is the problem come? The problem is that the problem comes actually here. Not only the space is the problem. I have 3 kinds of problem over here. And the first one is, let's understand the problem, then all of the confusion will go away. Okay, so try to understand this here. Here the problem that I have is insertion. Okay, the problem that I have is insertion anomaly. Then I have second one is deletion also. Okay, then I would have the problem in updating also. Okay, let me tell you how. Let me tell you how. Like, these are the insertion, deletion, and updating anomaly. ANAMOLY. No, my handwriting is not being clear. This is ANAMOLY. Okay, I'm talking about the problem. These are the problem. So let me talk about the problem. The problem is insertion anomaly, deletion anomaly, and updating anomaly. Okay, so what is anomaly? Anomaly is means problem. Okay, such a problem that occurs on a special occasion, we call it as anomaly. Okay, let's start with the insertion thing. We will first start with the insertion thing. Like, if I want to insert something in the table, then is it going to create a problem? For example, I want to put a value of a put the data of a new student. Okay, I want to do what? I want to put a insert a new record in my table. Let's say that a new student has taken admission in the university. Let's say it's a database of the school or the university. Okay, now I have a student with the SID 6. Okay, new student is over here. Maybe the name is Varun. Okay, so the problem is that this student has, we can easily insert the data over there. Okay, inserting the information of the student is not a problem. That I would insert 6 and Varun over here, maybe it would be null, null, null. Okay, because this is not any kind of constraint. So maybe I can have null over here. We can easily insert the data over there. But let's take another case. Okay, for example, if the university start a new course. Okay, let's say that university started a new course. That means maybe it's a C10. Okay, and the name of the course is MBBS. Okay, the university started a new course. that is C10 and MBBS over here, then I want to insert the record or the value of the course only in this table. Okay. I want to insert the new value for the course only, that the university introduced a new course that is MBBS and the ID is C10. But there isn't any student who has taken this course yet. Are you guys getting the point? There isn't any student who has registered or taken this course yet. So for this C10 and MBBS, I can make it null. I can make it null. Or maybe this can be empty. This can be empty. But can my primary key field be empty over here? Can my primary key field be empty? I cannot do that. Right, it's a primary key field and I cannot left it empty. Okay, for if I, what if I put a dummy value, maybe I put a dummy value something like has at the rate, then it is going to create so much problem in the table and it would lead to a more complex problem if you put a dummy value. Okay, because table works in a row and column and we need to keep that in mind. The updation and deletion would be very much, it would create a great problem. Okay, so here this is the problem, that you cannot insert a new data in this table where you have three different categories. You have the record of students also, you have the record of course also, you have the record of the teachers also. Okay. So if I will try to introduce a new course and put a value over here, neither any teacher has been assigned to this course nor any student has taken this course. Okay, then how can I, but it's a compulsory, there's a mandatory situation that I need to include this course in my database. Then don't you think this is a problem now? So this is a huge problem, that I cannot, even though if I want, I cannot insert a value in this table. So that is what insertion anomaly is. Okay, and normalization will help us to overcome that problem, and we will understand the solution also. But right now, are you guys able to understand the problem, how insertion problem will take place if the table looks something like this? Okay, so basically if we, I want to insert a new value, I cannot add the 6 over here because this is student ID. Okay, this is student ID, so you cannot add 6 over here. What I'm trying to say is that the scenario or the situation is a new course has been introduced. Okay, the new course has been introduced, but none of the student has taken it yet. No one has registered for this course. Then if nobody has taken this course, what is the name that you are going to write, or what is the ID that you are going to write? You don't have any idea. But of course, the university has introduced a new course and I want to insert it somewhere. I want to keep the record of it. Okay, maybe the admission will take place like after half an year, after the teachers are assigned, after the subjects are assigned, duration is decided or anything. Okay, so that's the problem, that this is my primary key field and I cannot have null value over here. So if I want to insert a particular at column label, okay, if I want to insert a value at column label, then I cannot do that. Okay. And what is the solution for it? Would be, the solution is that you create a different table for the course, and that is what the normalization is. Okay. As I told you, we will understand the solution after some time. Let's understand the problem first. Yeah, the people who are asking me, can we create the table differently? Yes, we can. Of course, the solution is that we will create the different tables. Okay. And that is what the normalization is. And that is what we will implement this in the table. Okay. We cannot insert this data at all over here. That's why we cannot put anything in the primary key. There is not any classes on Saturday and Sunday. Regular classes only over there. This master class is not on weekend, only on weekdays. Okay. So in the same way, if I talk about this deleting process, okay, if I talk about, I'm getting so much questions, but I'm sorry. Let me complete this topic, then I'll be answering your questions. Okay, please let me complete this first. So about the deletion anomaly, in order to delete something, what can I do is that, for example, I want to delete the record of the Sanvi. Like this student left the school. Okay, the student left the school, so I want to delete the information of Sanvi only. I don't want to delete the information of the courses, of the course, or the teacher who was teaching. Okay, the thing is that we have not read this yet, but here's a query. The query in order to delete something is we write delete. Okay, then we write from, then table. Maybe the name of this table is student. Okay, so delete from student, and if I where we define the condition id is equal to 5. So what is this gonna do is this is going to delete the record of the person with the id 5. So it will delete all of this. Okay, it is going to do what? It is going to delete all of this. Do I want it to delete the course name? Do I want it to delete the information of the teacher? Do I want it to delete the information of the teacher, that is salary or whatever? The student only left the school. Okay, the student left the school, so I want to remove this only. Why should a student leaving the school should hamper the information of the course and the teacher? It should not, right? So this is called deletion anomaly, because it is going to delete the whole row. Okay, it occurs on a special cases. Okay, like if I want to delete something, I want to delete the information of a student only, but it is deleting all of the row, which I don't want. In the same way, if I want to update something, if I want to update the value of a course, okay, then instead of updating a single thing, it is going to update everything. Like for example, okay, if I talk about the updation anomaly, so let's consider that. Okay, here let's consider that I want to update the value of the ram. Okay, I want to make it Rampal or something. I want to just make the name in the change the name of this student. He was like Ram, but change and make it to the Rampal. So what I will do, I will use the query. Okay, where his id is 3, where his id is what? 3. So it will change the name from Ram to Rampal. So there isn't any problem. I will write update table set student name is equal to Rampal, where id is equal to 3, and it is going to do that, right? There isn't any problem with it. But the problem will occur, okay, like if I want to change the salary of any teacher, like for example, okay, for example over here, I want to change the salary of the John. Okay, here maybe the John who is teaching over here, and make it what? Make it 40,000, from 30 to 40,000. Okay. So if I apply the condition, like update the salary where teacher ID is equal whereas teacher ID is equal to T1. If I apply this, then it will change over here also, here also, here also, and in all of the rows. Okay. So means at that times the number of time the T1 is appearing, it is going to update all of the salaries over there. Maybe if I want to make the changes in the course, okay, like John was now teaching RAM DBMS, but I only want to change that now he is teaching C. Okay, so if I will apply that, if I will make the changes, like if I write update name of the table, um set course name is equal to C. Okay. For the C1, John was teaching that to Ram. Then it will update here also, and it will update here also, and it will update for the John also. Okay. But John is teaching, still teaching DBMS over here and over here. So it's like so much of confusion and so much of invalid data. So, so much of problem that would be appearing if we have all of the information gathered in the same table. Like I have student information also, course information also, and teachers information also. Okay. So this is what the problem is. Okay. Like you people might be thinking, like, why do we create different tables in a single database? Why don't we create a single table and store all of the information over there, right? So this is the what kind of problem will take place if you we will try to store all of the information in the single table. Okay, this is a table. Right now here are only 4 to 5 values, but I'm getting so much problem. What if there are lakhs of data? Okay. If we will include all of this thing in same table, then these are the problems that we can get. Like inserting is a very tough task. Okay, we won't be able to insert something. There can be only one primary key. We won't be able to update the things properly. We won't be able to delete the things properly. Okay, so these are the problem that we will have, and normalization is going to help us to overcome this problem. Okay, so what does the normalization, what does it do? It removes redundancy from here. It is going to remove the duplicacy. So it has different rules. Okay, it has a different rule. How can we do that? Like all of you were already come up with the solution, right? The solution is very simple, that instead of storing all of this information together, what we will do is that we will create different tables, right? I will have a student table. Here I will have SID, and here I will have S name. I will make this as primary key. So it will handle all of the information of the student. In the same way, I will have a course table differently. Here I will have CID, and here I will have CNAME. And this CNAME is going to be what? It is going to be the primary key of the course table. In the same way, I will have teachers table, right? Teachers table, here I will have tables ID, and here I will have the teacher's ID, teacher's name, and other information. And this teacher's ID is going to be my primary key. Okay, so this is what we can do. We can create three different tables and store the results separately. Okay, then there would be no problem. Okay, if I want to insert the value for the student, I can insert it. If I want to delete that, I can do it. If I want to insert the course, I can insert it over here. If I want to insert the teacher's information, then I can do that, delete or update or anything. Okay, I can do that over here. How we have created 3 different tables if we have lakhs of records. As I told you, if you have lakhs of records in the single table, then you will have a problem. So before having those records, the initial step is that create 3 different tables. And that way we studied ER model, that instead of creating a single table, create ER model. Identify what are the entities required. Identify what are the tables required. Okay. And then create them separately, and then we need to link it with each other. Okay, so in order to perform normalization, this breaking down, yeah, it is going to be applied in initial step only. It's not like you are going to create three different table after putting the lakhs of data. That is going to be so much of hectic task, and we don't do that. You, okay, suppose we have already created this table, then what to do? Like, which table are you talking about? That's why we are learning that we are not supposed to create such kind of tables in initial stage. If we are learning this, that's why we are learning this theoretically, that we are not supposed to create the table like that. We are supposed to have a ER model and then create the different tables. Okay, so if there are like lakhs of student, the lakhs of records would go in student table. If there are hundreds of codes would go in this table. If there are like thousands of teachers, then that would go in the teachers table. Okay, okay, let's understand the normalization process. Let's understand the normalization process. The first thing that I told you is that we can define three different tables. Okay, but if we have the always our first concept is that we don't create a table which has lakhs of data and then divide it. But if that's the scenario, if we have already created it, okay, and if we have a data, then we need to break it down later on. Now, how can we do that? And that is normalization. Okay, we have three different kinds of normalization. That is, first one is first normal form, then I have second normal form, and then I have third normal form. Okay, so we will understand this each and form separately. First normal form, second normal form, and third normal form. So we are going to discuss the first normal form initially. Okay, so what is the rule? We have some rule that we need to follow while applying the normalization. We have the four. So according to EF code, okay, EF code is the father of DBMS. The first rule of first normal form is that we'll talk about the first normal form. The first normal form is that table should not contain any multi-valued attributes. Okay, what does the first normal form says? It says that the table should not contain any multi-valid attributes. Means in a table, there should not be a single attribute in which more than one value exists for a single particular person. Like, for example, if I have a student table over here, okay, if I have a student table, here I have a roll number, here I have name, and here I have course. If this is what the table, this if this is the table, okay, if I have table this, then the first normal form says that table should not contain any multi-valued attribute. Okay, for example, if I have here 1 2 3, okay, maybe the name is Sai, then I have a name hers, okay, and then here is Omkar, okay, maybe the course is here C, here is Java, and here is he's taking two courses, C and DBMS, okay, and he's taking C and C++. So these are some values in it. So what is the meaning of that? Now here if you see roll number 1, Sai has C, C++. What is the meaning of that? Sai has registered in C and C++ both courses. Okay. It is possible that a single person can take two courses. Like I can learn C and C++ at the same time. Course or subjects. Okay. Then a student has enrolled in more than one course. Here, what is happening? A single student is taking more than one course. But the first normal form here, the motive is that how to represent it. Okay, the representation is wrong. Even the size taking C and C++, the representation is wrong. We cannot represent like this because there is more than one value for a student. Apart from courses, there can be addresses, right? More than one value of a student. Phone number can have more than one values. So if you look at this table here, I can clearly say that this table is not in first normal form. Okay, because course, what is the problem here? The problem here is that in course, okay, there is more than one value. First normal form says that tables should not contain any multi-valid attributes. Okay, that is what it is. So for this Sai and Omkar, okay, there is more than one value. So that even if a single course, a single attribute in your table whose value is more than one exists, then you can clearly say that table is not in first normal form. Okay, we can say that because for this course, I have multi-value. So this is not in first normal form. So if you get such representation of a table, then you can clearly say that no, the table is not in the first normal form. Okay. Now the second question comes, how to convert this table into first normal form. So we have some solutions for it. Okay. The first solution is draw a table. Maybe here I have roll number, then name, and then course. Okay. Over here, attribute, the attribute is going to be same that I have. So what can I do? I can divide it. Like here I can write 1, size, I would take C. Again here 1, size, and then C++. Okay. Then for 2, here is hers with Java. Okay. Then 3, then Omkar, and then C, then again 3, and then here Omkar, and then DBMS. Okay. The representation will be something like this. So if I divided the table like that, a row, which is a roll number, I have written it multiple times. But if you are asked that what will be the primary key in this table, what can be the primary key in this table? Yes, you people are already asking me the question over here. So I'm also asking so guys, you can clearly check that there are repeating values and there cannot be a primary key. Yes, name cannot also be a primary key. Roll number also cannot be a primary key. Course also cannot be a primary key because the values are repeating. So if I combine a roll number and course, if you see carefully, if I will combine here roll number and course, then definitely it will be the primary key. If I mention here separately, then primary key will be the combination of roll number. The codes cannot be primary key because C and C is repeated. Here C and C is repeated. That's why it cannot be. Okay, so what can be the primary key is the roll number plus codes. Okay, combined. And this thing is called composite primary key. We are learning a new concept over here. Okay, we know about primary key. We have up to now we learned that there can be one primary key, okay, but there can be a scenario in a table where you need to uniquely identify a record, okay, but all of the values are being repeated in all three columns. Okay, so you can see that this is column level duplicacies over here. Okay, So if there are values repeated in the column label, then what I need something that can help me to uniquely identify a record. And that is my composite primary key. And that is the combination of roll number and course. Okay. So this is the first representation like that. The second representation will be the same table. Okay. One more thing, that the second representation can be, here I will have the same table, roll number, name, here would be like roll number, name, and course. Okay. Now guys, in the courses, what will happen is that I know that what is the maximum value of the course, means maximum number of course a student is rolled in here. A student is rolled in maximum how many courses? 2 courses, right? So what can I do here is that I can make a separate column. I can make here course 1 and course 2. Okay. So I can do what? I can have a course 1 and course 2. So the roll number 1, okay, name is Sai. He is taking 2 courses. Course 1 that is C and the course 2 that is C++. Right? Then after that here I have 2, and then 2 is who is Hertz. He's taking only 1 course Java. Here can I store null value for the course 2? Because he has not taken any second course, so it would be null. Okay. In the same way, there is 3. And here is Omkar. He's taking 2 courses. So here can I have C and I can have DBMS. Okay. So now the important part is what will be the here. This is null. I have 3 Omkar, C and DBMS. Okay. So this will be the second kind of representation. So in this way, in this, you can be asked what can be the primary key. Okay. The same question over here. What can be the primary key in this table? The primary key directly can be your roll number. Right? Here the roll number can be the directly your primary key. So we can say that it is simple primary key, that is a roll number. But if you see in this, okay, then what problem is that there can be possible that a student enrolled in n number of courses, okay, and another student enrolled in one course. So what will happen, guys? For one, you are writing columns again and again. You are writing n number of columns. Okay. Here, the problem is if there would be multiple courses, maybe other courses are introduced. Then there can be, I can have course 3, course 4, course 5. Maybe a single person is taking 5 courses or 6 courses, then I can have your 6 course column. So here can I have n number of course, right? And maybe this hers, out of this n number of courses, hers took Java only. So for course 3 also it will be null. For course 3 also it will be null. For course 4 also it would be null. For course 5 also it would be null, and it can go up to null for the n number of courses. Right? It can happen. Such a situation can happen. So many times null can appear. In this case, what will happen is that many times null can appear in overall table. Then there will be more number of nulls in the representation, which is not a good representation. If you are creating a table and you are seeing null all over the table, then that is not called a good representation. Okay. So we find out the first solution, we find out the second solution. Now we have third representation also. Okay. What can we do is that we can divide this table into 2. What can I do? This is my first representation. This is my second representation. Now the third representation that I can have is that I can divide this table into 2. What can I do? I can write roll number and then name. Okay. Here I will have roll number 1, 2, 3. And here would be Sai, here would be Hers, here would be Omkar. Okay, I'm dividing the table. Now I will have a second table. That would be my course table. So here I will write roll number and then here I will have course. Right. So this would be my primary key. Okay. Everything is sorted in this table. Roll number 1 is taking which course? Roll number 1 is taking C. Roll number 1 is again taking which course? C++. Roll number 2 is taking Java. Okay. Roll number 3 is taking C and roll number 3 is also taking DBMS. This roll number here is primary key. This roll number can be my foreign key. Yes or not? So whatever the student that have enrolled in my, if this is my primary key, then the foreign key is going to have only those values that is in my parent table. Yes. So here, if this is my base table, because as a parent table, this has the primary key. We are calling it base table, okay? Because in this primary key will exist, that is roll number. So the roll number will exist as a primary key, and we will reference it in this table. I will name it as course table, right? In course table, this primary key will act as what? It will act as the foreign key. As we already know, foreign key always takes the reference from the primary key. Okay, so in this table, primary key is roll number. Here it will take the reference, it will be foreign key, and we can store the multiple uh and what can we do? We can store the multiple datas in it. Okay, foreign key, the person who is asking me, it accepted a repeated value. This is not primary key. In foreign key we can have repeated value. In foreign key we can have repeated value. Okay, here. So this was the first approach, it didn't work out. This was our second approach, this also didn't work out, and we had our third approach. Okay, so here you can see that table should not contain any multi-valid attributes. So in a same cell, we cannot have multi-values, okay, in a same cell. So how did we come up with the problem? In the first normal form, created two different tables, roll number and name, and then roll number and course. And we created link between these two tables. Okay, then what happened? Now what happened here is that rule our problem has been solved for this one. Okay, our problem has been, this is our first normal form is, if you have any table, you can convert it into first normal form in three ways. Okay, these are the three ways, but out of this, which one is the best method? You can take it in your own way. Either you want to go with this way, here also we don't have multi-value, here also we don't have any multi-value, here also we don't have any multi-value. Okay, so you can go for whichever the thing you want and create or apply the first normalization method in the table. Okay, is this clear to you all? We have second normal form also and third normal form also. Column level duplicacy. I thought I already explained. Row level. Can you see this here? Column. This roll number is a column, right? Here 1 and 1 is being repeated. 3 and 3 is also being repeated. So this is column level duplicacy. And when there is column level duplicacy, you cannot make it primary key. We have discussed first normal form only right now. After this, we'll discuss the second normal form and third normal form. Yeah, this was all part of first normal form only. How multi-value is course name and attribute is student. Student is not attribute. A student is entity. Student is the table name and course name is multi-valued because in course you can see that C/C++, C/DBMS. In a single cell, I have multi-values. That is what multi-valued attribute is. And it should not be allowed in the table. Yet these all three representation are in first normal form. Okay, how to have a composite primary key? So composite primary key here works the basically like a normal primary key, but while creating, okay, for example, if you are going with this particular formula in this particular way, then you will have a primary key that is the combination of roll number and course, right? So in order to have a composite primary key, what we do is, like, do you guys remember, like for id, we how do we used to create the primary key? Id int, and then I used to write here primary key, right? Do you guys remember that syntax? But if you want to create a composite primary key, then for composite primary key, what I will do here, this would be my create table. Okay, table name, whatever it is. Then after that, I have three columns, right? So here I will write a roll number. Then it would be int. Then after that, name, varchar 10. Okay, then course, varchar and 100 or something like this over here. Then I would decide my primary key like this. I'll write here primary key. And since I want two, right, that combination, composite primary key. So here I write the column 1 and column. That means I'll write here roll number, then comma, and then course, like this. Okay. So now in this way, I have a composite primary key. So my records will be identified on the basis of this combination. And the function is going to be as same as a normal primary key. And remember that the combination should be unique. Like here is 1 and here is C. 1 and C++. It is unique. 2 Java, 3 C, 3 DBMS. If you will have 3 and again C, now that would be a duplicacy. Okay. Is this clear? Composite primary key. Composite primary key means the combined value should be unique. As I told you, composite primary key approach is not efficient. Okay. It's not efficient. We should have primary key because that would create so much of a mess in order to have two values as a unique. In case of composite key, how table will stop me to put not null values, just like the primary key works. it's still a primary key, no? But it's a combination of two things. So if you will try to insert any null in the course column, or if you will try to insert a duplicate value in the course column, then you will get an error. If you try to repeat the same thing, then you will get an error. Okay, now we'll talk about the second normal form. So you need to remember the rules, okay? I wrote the rule for the first normal form. Now, in the same way, we will, in first normal form, you cannot have a multi-valued attribute, okay? In the same way, in second normal form also, we have some rules that we need to follow. The first rule says that table or table must be in first normal form. First rule says that. Table should be in first normal form. That is the first rule. And the second rule is that all the all the non-prime, I will tell you what are non-prime attributes, so don't get scared. Non-prime attributes should be fully functional dependent on candidate key. This is normal form. NF means normal form, okay? So we will understand each and everything, like what are these non-prime attributes, what this means, what does this fully functional dependent means, okay? And what does this candidate key means, we will talk about each and everything. We'll talk about each and everything, candidate key, non-prime attributes, fully functional and everything. Okay. If I have a table over here, okay, so maybe this is customer ID. After that, here I have store ID and I have location. Okay, if this is a table given over here, maybe I have some values. It is like one store ID is also one, location is Delhi. Here I have one store ID is 3, location is Mumbai. Then customer ID 2, 3, 4, 1, 2, and 3. This is Delhi, Bangalore, and again Mumbai. Okay, so this is the table. Now I have written here rules. We'll go through the rules one and again. Here the table should not contain any partial dependency. Okay, and we can write in that format. The table will be in second normal form. Okay, here two rules are given. First thing is that it should be in first normal form. This must be present on first normal form. What does the first normal form means? In any of the column, I should not have repeated values. Like I cannot have Delhi slash Mumbai like this. Okay, I cannot have 1/3 or something like that. Okay, that is what the first normal form says. There cannot be multi values. So my table is already in first normal form. This is in first normal form, there isn't any problem. The important condition is all non-prime attributes of the table should be fully functional dependent on the candidate key. Means now the second normal form, okay, the rules for the second normal form are the table must present in first normal form and the table should not contain any partial dependency. We can write it in that format, okay? Now the important condition is all the non-prime attributes of the table should be fully functional dependent on the candidate key. Means what are non-prime attributes? The attributes which is not participating in the formation of candidate key. Okay. Non-prime attributes are those. Am I audible? Okay. I guess I'm audible now. Okay, so candidate key is something. Let's understand what is this candidate key first. Okay. Candidate key is a set of one or more columns that uniquely identify each row in a table. Okay. Like we have a condition with primary key. That primary key is always a single column, right? If I have like 1, 2, 3 column, then either customer ID would be my primary key or store ID would be my primary key. Okay. But candidate key is something, it's like a set of one or more columns that uniquely identify each row in a table. It can be single also and it can be combined also. Okay. There's a difference in candidate and composite key. We learned composite key a couple of minutes before, but there is a difference between them. Composite key is something, okay, when you combine two things together, when you combine two columns together, okay, that was the composite key is what? If roll number was my primary key, but if I combine it with course or any other column, then roll number and course, both of them together became my composite key in the last table. Yes or not? So candidate key can be both. The candidate key means here I can have customer ID only as the candidate key also. Okay. Or I can have like the combination of the columns as the candidate key also. That will help me to uniquely identify each row in a table. Okay. It could be a single column or combination of column. Okay. And it helps us to satisfy the uniqueness. That is what candidate key is. Are you guys able to understand this? Okay, let me give you one example. Here in this table, if you look carefully, okay, in this table, if you look carefully, then a custom, I have three columns, right? I have three columns over here. So if I will combine customer ID and store ID, this is one. First of all, what combination would I have? I will have 1 and 1. That is unique, right? Second, I will have 1 and 3. It is different from each other. Third, I will have 2 and 1, different. Okay. Then I have 3 and 2. Then I have 4 and 3. So you can see that the combination of this customer ID and store ID, this can be my candidate key. Okay. This can be what? This can be my candidate key. Okay. That is one scenario. And other scenario is also that. Also, if no, other scenario is also that if I had something like this, okay, if this was not over here, consider this case. If in customer ID I had only unique value, like if I had 1, 2, 3, and 4. Okay, this is one case. So this can be my candidate key. But can this be my composite key? Can this be my composite key? No. This is one case. Another case is that here the combination also like 1, 3, okay, then 2, 1, then 3, 2, and then 4, 3. This also can be my candidate key. Okay. So basically, how can you understand is that primary key or composite key? Okay, candidate key is something. Primary key is what? That have only unique value in a particular column, right? Right now, if you look into the table, if I remove this value, okay, then right now, which one would be the primary key in my table? Which one be the primary key in my table? Customer ID, right? Primary key can be my customer ID. And primary key my customer ID. If I have something like here 1, and then here I have 2. Now, if I will write this combination 1, 2, 1, 3, 2, 1, 3, 2, and 4, 3, that can be my this both can be my composite key. Can it be my composite key or not? So basically, candidate key means either primary key or composite key. You can take a choice according to your table. Candidate key is just another term for primary key and composite key. The way to define the candidate key is going to be same. Like it's up to you what you want to do. Like if right now, if I look at my table, okay, like right now, if I look at my table, I have multiple, I have repeating values in customer ID column also. I have repeating values in store ID column also. So neither I can make customer ID as my primary key, nor I can make store ID as my what? Primary key. So I have another option. What is the another option? To have a composite key. Yes or not? So the thing is going to be same. Like just like I told you, how will I define it? I will write primary key. Okay. And primary key, and then I will write here customer ID, comma, store underscore ID. Okay. So basically, how can you understand it that primary key is one thing, composite, what is this spelling? Composite key is another thing, right? I hope you people are clear about these two things. Candidate key is both. So sometimes in table, either you can have only primary key or you can have only composite key. Okay. So we use term. It's like a English word. It's a term that instead of writing candidate key, I can also write primary key or composite key. Okay. I can write this thing also. Composite key like this. But if I want to denote both of the words together, if I want to denote both of the terms together, then instead of saying primary key or composite key, I can directly say candidate key. The criteria of composite key is that it should be unique in pair. It should be unique in pair. That is the criteria of composite key. Okay, do you guys understood this? What is the candidate key? Is just like a term or a English word that it's an alternative way to call primary key or composite key. No, null is not allowed in composite key. You can see that this is the way you create a composite key. Okay, so of course you cannot have null over here. Okay, are you guys clear about this term that is candidate key? What is the difference in primary key and composite key? Primary key is a single column, composite is a combination of a column. Yeah, no, rows can be uniquely identified by composite key. Composite key is same as primary key. The only difference is primary key is single value, composite key is pair value. That's it. When did I say the null is allowed in candidate? In prime foreign key null is allowed and repetition of value is allowed. Okay, now let's talk about the second normal form. So we understood what is this candidate key, and the things is that the non-prime attributes should be fully functionally dependent on candidate key. Okay. So what are non-prime attributes? The attributes which is not participating in formation of candidate key. Okay. What is it, people? What is non-prime attributes? Yes, composite key and composite primary key is same. Okay. What are non-prime attributes? People, listen to me. Non-prime attribute means the columns that is not taking participate to create your candidate key. So your customer ID and store ID will take place. So here this location is my non-prime attribute. Okay. Let me repeat one more time. Non-prime attributes are those which does not take part in the formation of candidate key. Okay. So I will make a candidate key that would be cust ID and store ID. So in my table now location is my non-prime attribute. Okay. And they want to be functional dependent. That means they must be present on the candidate key. They should not depend on the part of a candidate key. Okay. Or you can say the subset of the candidate key. Let's with this table, let me make you understand this. Okay, here I have this customer table. I have customer ID, store ID, and a location. Okay, the primary key, or you can say that the candidate key over here, if I candidate key is what in this table? Candidate key is going to be what? Customer ID plus store ID, right? Candidate key is that. Yeah, other than candidate key, we have this non-prime attributes. Okay, this is our candidate key. Now, what are our prime attributes? Prime attributes, if location is non-prime, then prime attribute is customer ID and store ID, right? And what are non-prime attribute? location. Non-prime is location, right? So these are the three things that we need to understand. Candidate key, okay, and then prime attribute, and then non-prime location over here, okay. So if you see the location, okay, if you see the location over here, like this is Delhi, Mumbai, Delhi, Bangalore, and Mumbai. As I have discussed in the, we have discussed that these are some values over here, okay. Uh, this location, if you see the location over here, this is my non-prime attribute. And how can I say that? Because candidate key is formed with customer ID and store ID. So what are the prime attribute? That is customer ID and store ID, and my non-prime attribute is location. Okay, simple. Now, according to the rule of second normal form, all the non-prime attributes should be fully functional dependent on candidate key. Okay. Now, see the non-prime attribute, that is location. Location must be fully functional dependent on the candidate key, means customer ID, store ID combined. Okay. But if you check that carefully, that location is in this table, the location is dependent on store ID only. Okay. So this my non-prime attribute should be fully functionally dependent on candidate key. That means my location should be dependent on customer ID also, store ID also. But if you will see the table, okay, but if you see the table, my Delhi or my location is dependent on store ID only. How is that? Okay, here, how is that? Let me tell you. Here, this Delhi. Okay, Delhi. Delhi means if I have a confusion that Delhi is once, it is the same value, right? Delhi over is here. I don't know. Here it should be, both of the Delhi have the same store ID, so it should be one. Okay, I have wrote the two. It should be same. So for Delhi, store ID is also one over here, and for this Delhi, also the store ID is one. All right. Are you guys getting the point? It is the same value. That means, or these are two different values. So if I check the store ID one means that the store ID is determining the location. Okay, here if you see Delhi value is one, store ID, Delhi store ID. Customer ID is what? One. Here customer ID is two. Because customers can be different, right? But the stored location is, the ID for the location is going to be same. This is stored location ID. Store ID. The location. Because of the store ID, I can identify the location. Customer can be from anywhere. Is the, do you think this the person whose customer is the do you think the customer whose ID is one is also from Delhi? Or do you think this customer whose ID is two is also from Delhi? No, right? We don't have any information of the customer in this table right now. We have the only ID of the customers. Are you guys getting the point? So location is not dependent on customer ID. Location is only dependent on store ID in this table. Okay, means that store ID is determining location. Now, if you see Mumbai, okay, here Mumbai values are same, store ID is also same. So according to functional dependency, if the right hand side values are same, then left hand side must be same. Okay, so what is the meaning of this? The location is determined by the store ID, which is table. So this table is not in second normal form, right? It should not be what? It should not be in second normal form. Then what do we need to do? There is a problem over here. This is not in second normal form. It is in first normal form, but it is not second normal form. Fully functional means all of the values should be dependent on candidate key. So what is the solution over here? People will divide this. Okay, we'll divide the table. How I'll divide it? I'll make a new table. So here I will have customer ID. Okay. And then here I have store ID. This would be my one table. Okay. What is this going to be? This would be my one table. And here customer ID 1, 1, then 1 and 3, 2, then 1, and then 3, 2, 4, and 3. Okay, this would be my customer ID and store ID. In the same way, I will have another table. That is my store ID and location. Store ID and location. So for 1, I will have Delhi over here. Okay. Then after that for 2, I'll have Bangalore. Right. And for 3, I'll have Mumbai. Do I need to repeat the value? No. Do I need to write one Delhi and one Delhi again? No. Okay. For 1, it is Delhi. For 2, it is Bangalore. And for 3, it is Mumbai. Okay. So these are my two tables. Here, these are my two tables. Then what will be the primary key? The primary key, or we can say the candidate key, is going to be my store ID. Right. And here, this store, we can say that here I can say that this is my candidate key, that is store ID. Okay. In this table, candidate key is my store ID. Okay. And now in my second table, you can see that the value is being repeated here also. And the value is being repeated here also. Right? The value is being repeated in both of them. So what can I do now? I can have a candidate key that is a combination of both of them. Right? I can have a composite key that is. So this would be my candidate key over here. Okay. So now you can see that all of the values are directly dependent on the store ID. Right? All of the locations are directly dependent on the store ID only. So this table is in my second normal form. And since this is my candidate key, if there would be any other attributes or value, that is going to be dependent on both of them, because this would be when I would create this as my customer table. I'll keep the record of the customers. Okay. So, and they would be identified on the basis of customer ID and store ID. So in this way, we can break down the table and we can have our second normal form. Okay. And if there isn't any more column, then no need to make it as a candidate key or anything. This is the non-prime attribute itself. And we can say that this table is in second normal form. Okay. So this is what the rule of the second normal form says. And this is how we can achieve the second normal form in our table. Okay. So basically, normalization is like breaking down of the tables in such a way that there is not redundancy in the data. Okay. Is this clear to you all? No, candidate key should be from the same table. Okay. What exactly different between two table is that this table is not in second normal form. Not in second normal form. Second normal form means here you can see that the location non-prime attribute, this is the non-prime attribute. Second normal form rule says that non-prime attribute should be fully dependent on the candidate key. Here my candidate key is both of them. Okay, but my location is only dependent on store ID. It is not dependent on the customer ID. So this is not in second normal form and we need to convert this table in the second normal form. So if I will divide it in this way, then okay, we will get what? We will get a table that is in second normal form where this is my non-prime attribute. It is directly dependent on my store ID. Okay, here I don't have any non-prime attribute. So this is already in my second normal form. Full functional as in fully dependent. So before getting to the practical part, we need to understand the concept. Okay, that's why I'm teaching you theoretically first, because first of all, we need to understand the concept, how would the table would look like. Then after that, we'll be implementing it. Okay. But yes, the practical will happen for sure. It's like the before riding a bike, we are learning the parts of the bike, like which one is the accelerator, which one is the brake, what up to how much the meter will go and all. So basically we're learning that. Then after that we will implement it practically. No, you can practice it on your own. No need to send me the model. Just practice the ER model of the library management system on your own. So basically third normal form is remaining. Okay, so I will discuss that third one normal form. Then tomorrow in class, what we will do is, uh, tomorrow what we will do is that first of all, I'll make you understand the third normal form. And then we will have tables on our SQL workbench. Okay, then we will learn about joins. Okay, like how will we extract data from, if we are creating two to three different table, then how will we extract data from the two different table. Okay, this master class is about database management system. Yes, you need this concept, of course you need this concept in interview, that's why we are learning it. And DBMS is more like theoretical concept. SQL is a practical thing, but DBMS is a theoretical thing where you need to understand the terms and terminologies. What questions will be asked from normalization? Like, what is the rule of the first normal form? Or what is the rule of the second normal form? Or what is a candidate key? What is a composite key? Why do we need normalization? What is normalization? These are the questions that can be asked to you. Soon, it will happen very soon. Okay. So is everything clear? Theoretical session, I think it is tomorrow. We will start the joins, that will take all of the practical thing only. I will talk about the like operator, aggregate functions, that will be totally practical. Basically, if we are talking about SQL, then that is practical, but DBMS, okay, SQL is a part of a DBMS. Like if this is DBMS, okay, then SQL is inside it. Okay, DBMS is itself a theoretical concept. Inside this SQL is a practical concept. Okay, so first of all, we are learning this. We have some topic. We started with SQL. Do you guys remember? Right. Then now we are learning DBMS. Right. Then again, I will go back to the SQL. I will teach you some practical questions. Then we'll learn about the theoretical concept, and then we will implement it. And I'll give you one project that you will implement on your side. The person who is asking me, will there be no Saturday and Sunday classes now? I have like, I think you asked me that questions 10 times already. Okay. And I answered you already also. Maybe you didn't notice. Saturday and Sunday, you have regular classes. For your batches, you have regular classes. Yes or not? Whatever the classes that goes on. This master class is for the weekdays only. Yes, you can leave now. Okay. So the time is also over, people. Thank you so much for joining today's class. Now I'll see you tomorrow. The classes will be assigned if you, yeah, this class is for the weekdays only. Yeah, the notes will be provided at the end of master class. All of the notes that I'm teaching you right now in the class, each and everything will be provided to you at the end of the master class. Saturday and Sunday, there isn't any class. Okay, master class is not on Saturday and Sunday. Master class is on weekdays only. We will finish this master class during this week. Okay, thank you so much. People have a great day ahead. I'll see you tomorrow. Good night. Yeah, I will provide you live project also. The projects will be given to you after completing some topics. Okay, then I'll provide you the project. Okay, thank you everyone.